right, so hello everyone, dzień dobry. I'm Janiczek from Czech Republic, and you can find me on the internet under my last name. And I want to share something about property testing, all the things in SerenityOS, or maybe not actually all the things, but I think it's still going to be interesting. So first of all, I want to say I love PBT, to which reasonable response on some other conference might be, what is PBT? So granted here, I think probably everybody knows, but for anybody who doesn't or anybody who watches the recording, let me give you a crash course. So PBT stands for property-based testing. It's probably best compared to unit testing, where you have a specific scenario in mind, specific input for your function under test, and a specific outcome. Right, we all know unit tests like this one. And in comparison, this might be how property-based test looks. And the main change is that it receives the input as an argument. And the input is random. And so our test function will be getting lists like 1, 2, 3, or 0, 0, 0, 0, 0, or the empty list, 3, minus 5, 42, whatever, just like random lists. And so compared to unit testing, property tests generate many random inputs to test with, and they will run many, many times and try various edge cases. So in this sense, they are basically generating test cases for you. And once the test finds an input that fails the test, it will try to shrink it down as much as possible and give you a counterexample with no unneeded detail. A value which, if you simplified it any further, the test would start passing, which is not what you want. And this is awesome for debugging, because often the problem with the function will be obvious just from the input that you were given, from the minimized input. And it's just uncanny sometimes how, what the randomized test find, and sometimes the bug is just absolutely clear from the structure of the input, from what remained once all the unneeded detail has been stripped away. But this fact that your test receives random inputs means that in many cases you need to get more general in how you think about tests, and you cannot use all the same techniques that you used with unit tests. So you need to think about what is always true. Laws and properties and specifications that are always true no matter what specific value you are using. For example, in our code snippet before, I couldn't have used the code shape, the test shape from the unit test, because I have no idea what to put next to the equal signs, right? I cannot say the random list, once it reversed, equals something. I need to do some other stuff. You need to find some property that it has at all times. So this is a very canonical example. If you reverse it twice, it's as if you didn't do anything to it. Maybe reversed list has the same length as the original list. If you count the elements, they will have this, the same number of that element as the original list, stuff like that. I will skip over this one. So, having described PBT to you a little bit, let's get back to the story. So I fell in love with property-based testing. I fell in love with the computer finding tricky edge cases for me, seeing some kind of empirical evidence that it doesn't, break at anything slightly unexpected. And I fell in love with the fact that it finds a way to tell me, no, your mental model of your program is wrong. What if you put this tricky value here? What if you, put 0 here, put an empty list, put something like that there, and it will tell you, no, your property, either your program is wrong or your property is wrong, but something needs to change. And so I became involved in some open source tooling for property-based tests. It started with the Elm test runner, which had support for PBT, but it was implemented in a way that made monadic bind hard to use. And monadic bind lets you decide which generator to use dynamically based on a value from a previous generator. And this is very common and very useful. And so it felt wrong that this should be somehow a second-class citizen. Like, we didn't even have the and then or bind function there. It got removed and replaced with something called custom. And the issue is that suddenly, in order to use that, you had to start using a whole new API, a whole new abstraction, like shrinkers. What is that? Like, no other function from the testing library needed me to use that. Like, why do I need to start learning about this? What's the hurdle? Why the weird API? And so I dove into why does it happen? While looking into this, I found out that there are 3 main different ways to implement PBT libraries, or at least that I know of. 3 big families, if you will. So the original QuickCheck for Haskell and Erlang, it pioneered the whole industry. And now it's not lost on me that we have the author of QuickCheck here, so I don't really it feels a bit awkward to start criticizing QuickCheck. So I hope John will forgive me. It might be possible that I just don't know that some things are possible with QuickCheck. But yeah, I believe each of these approaches has some pros and cons, so I hope it's fair to mention those. So QuickCheck has pioneered the whole approach, and it's almost by necessity as the first iteration, very simple, straightforward. The original version in the paper, in the QuickCheck paper, didn't even have shrinking, I think. There was no shrink function in the type class. But when I tried to find the earliest version, on GitHub and elsewhere, there was this import from Mercurial or somewhere. So part of the history is lost, but the earliest version I could find already had shrink function that goes from your generated value to a list of simpler values. And so this is how QuickCheck does shrinking. The thing is, there is no ideal way to generate those functions. If you let the library generate a shrinker based on the type of the value, and with Haskell you can derive everything, then it doesn't know about the stuff that you have done to the value while not changing its type. So imagine testing numbers of the form 100x, multiples of 100, and suddenly your test will start saying, the test fails on number 5. And that's not useful to you because you wanted to only test the multiples of 100. 5 is not in your input space, so you can't generate 5, yet the shrinker got there somehow and presented that value to you as failing. And to get properly shrunk values that make sense, you need to implement the shrinker yourself, the shrink function, and use new types or whatever. And in practice, that's big enough hurdle that people just turn shrinking off or maybe don't use PBT. So I think that's a pity because it lowers the usefulness of the tool and the overall adoption. Then there's the second generation of tools, the Hedgehog library from Haskell again. And for example, the Elm test runner that I was showing before was using this approach as well. And I think it's quite a big improvement because it gave you automatic shrinking, making the tool much more useful. It uses something called integrated shrinking, which bundles generators and shrinkers together into one lazy tree of possible values. And that allows it to keep the constraints. Because when you map over this kind of tree, So you generate integers, you map, like, multiply this by 100 over it. It will do that to all the values in the tree. And so the shrinker will only walk the tree, and it will always give you the multiples. So that's great. But it struggles with the monadic bind that I mentioned before, with generators depending on the result of a previous generator. And those shrink poorly for reasons that are hard to explain, or at least like with just my hands and words. Basically, once you run the bind function on the generated value and you start shrinking the result of the bind, you cannot go back because you would have to drop everything you have done and generate it again. So while the Hedgehog library just shrugs and gives you the best it can, it's imperfect, but it gives you something, the Elm test library instead said, no, I will not compromise. I will only let you use bind if you give me all the information I need to give you the best result. And that might be commendable, but it's a bit like perfectionist, and it resulted again in a hard-to-use API, and as a result, people didn't really bother doing that. People will not bother learning a whole new, abstraction just to use that. And so people either didn't write the test that they wanted to write, or they wrote a generator and said, just do not shrink, I don't care. But then, when the test fails, you get a huge value that, like, it's not clear why it fails. So, again, this is a hurdle in the developer experience, and it means that people will not bother. And in my view, it's a small miracle that people are testing and property testing at all. So why put obstacles in their path? I think the absolutionist approach is a little bit hurtful. And to my amazement, this was almost a miracle, I have found a third approach, spearheaded by the library Hypothesis in Python. And they use something they call internal shrinking. And it seemed too good to be true, because you get automatic shrinking in almost all scenarios. It works even when you use monadic bind. There's no need for the user to think about shrinking. It just has beautiful, simple API. Everything works. And it works by adding a layer of indirection and remembering the random bits that it's plucked from the PRNG. And it shrinks that list of integers and then uses the generator to kind of like parse the value out of that list of integers. And I was like, this totally solves my problems. We don't need that hard-to-use API. We can have and-then function in Elm. Why doesn't everybody use this? And so I got in touch with the Elm test maintainers and managed to implement version 2 of it with that approach. And I think at the moment, the Hypothesis approach is probably the best thing you can try to imitate if you are writing a property testing library. So just like look at what Hypothesis does, steal some of their ideas. They are very focused on developer experience, and I think that's a great goal in this area. So now a change of scene. I have been a long-time fan of SerenityOS. If you don't know what it is, Andreas Klink, a software developer who has previously worked at Nokia and Apple on WebKit, he has started writing an operating system, like you do, naturally. It was this kind of weird Mac OS 9 and Windows 2000 and Unix hybrid. And the aesthetic and the ambition and audacity of the goal, I think, probably just like pushed all the right buttons in people, gave them a nostalgia hit, and the project snowballed. People came in, started adding things, started fixing things, and it's just got out of control. It's kind of huge now. Nowadays, the project is nearing its 6th birthday, and in addition to all the other applications and utilities they have, it has branched out and they are writing a freaking web browser from scratch. And yes, I know what you all are thinking, and no, I don't think they care. They don't care that it's like a huge, massive project, like it's impossible, right? Like to write a browser from scratch. They just keep chugging on, implementing specs, and they just do their own thing. And this is very inspiring to me. I love to watch all the like monthly update videos and clone the project every now and then, run it, and yeah, it's just huge fun. So, I love PBT. I admire SerenityOS. Wait a minute. Can I do PBT in SerenityOS? I have checked their code base and they are only doing like unit tests, or they go straight for the AFL fuzzer, which it might be similar to property-based testing, but is a little bit heavyweight and has a different set of strengths and weaknesses. So in my head, the conversation went a little bit like this. In my favor, I have written property-based testing libraries before, from scratch. I can probably do this. Not in my favor, I have written them in Elm or in Haskell, in pure functional languages, and SerenityOS is written in C++. I have not really touched C++ since my high school days, and back then for me it was glorified C to write like Project Euler solutions in that would run in like 8 hours instead of 3 days, and instead of actually trying to find a better algorithm for the problem. So I knew next to zero about templates, L values, R values, references, forwarding, I don't know what else, vtables, concepts. I just don't know C++ that well. Okay. In my favor, I got really pumped just thinking about all the tests I could write. I just love, property testing, just finding these properties and like, boom, there's a bug. So I just imagined I would have a field day writing test here, test there, check that, I don't know, queues work kind of like vectors and stuff like that. I was salivating. So many opportunities for what to test, but not in my favor. If I go and write C++, do I need to give up on my, beloved algebraic data types, exhaustive pattern matching, all the stuff that Michael was talking about yesterday, all my, functional programming comfort zone? I didn't have a good answer to that. But anyways, I gathered my courage. I went to gauge interest on their Discord, and I got green light. Awesome. I can try to start doing this. Now what? I started by making an experimental C++ project outside of SerenityOS to explore the space. If I just start porting my library from Elm to C++, what issues will I encounter? Will I be able to solve them? And so CPP minithesis was born. The minithesis in the name is basically the author of Hypothesis wrote a minithesis repository as a kind of guide on like the core idea of how it works. So it's like, it doesn't have all the bells and whistles of the full library, but it has the core algorithm in one file. So I made CPP minithesis to just like get the core idea running, just a proof of concept. And it went pretty well. I managed to port it. I had a basic proof of concept working, enough to show that my automatic shrinking worked. This might be too small, I apologize. But notably, I kept the combinator API I was used to from Elm, meaning this is all technically pure. And that detail will be important later. And it worked. So it worked with STL, with the C++ standard template library. And being naive as I was, I thought this is just a victory lap now. I can just copy paste those files, somehow like plug into their CMake or whatever, massage it a little bit, I'll be done. That's not what happened. Most definitely not a victory lap. The thing is, SerenityOS doesn't use STL. So they have like a different prelude. SerenityOS does everything from scratch. They use something they call AK, which they jokingly pretend not to know the meaning of. Like, is it agnostic kit, Andreas Kling, a keyboard, who knows? Like, it means whatever you want it to mean. But anyways, it's homegrown standard library for their C++. And it feels quite different from STL. Things didn't really match one-to-one to what I had in my standalone project. Suddenly, functions weren't copyable. Stuff got distracted before I managed to use it. If I didn't move arguments, I was getting weird data crashes, data corruption left and right. The whole project was just a lot more, I think, constrained, and it had many more static analysis checks turned on, like the UBSAN, undefined behavior sanitizer, which is probably good. Like, it's good to have, good standards, but I'm sure all those decisions result in better code long term for them. But it sucked for me because I just wanted to run this code that I already had written in C++, and it threw rocks under my legs. It wasn't very pleasant for me. And I started calling for help because a lot of this issue I had no idea how to fix or what they even mean. I am used to manage languages, and in Elm you don't really have malloc or whatever. So I need some help. And I set up camp in the SerenityOS Discord and tried getting some help with my error messages. And the error messages, I was never so happy, so thankful for Elm error messages as when I was doing this on the side. In C++, for one error, you get a lot of context. You get 2 pages of context saying the thing that didn't work that you wrote was referenced here, that was referenced here, that was referenced here. So there's a lot of the signal to noise ratio isn't good. And perhaps with experience, you can sort of tune out some parts of it, but I didn't have that skill. And so on the SerenityOS Discord, they helped me. They got through all of these issues with me. And for that, I'm very thankful. They are awesome. So I ported this to SerenityOS. A very interesting thing happened in the middle of the development. The API that I'm used to from Elm, a pure functional language, is that there's a generation phase for the test and a testing phase. And you cannot mix between them. You cannot generate something in the middle of testing. And yeah, they are just isolated. And if you want a value to be generated based on some other value, you need to use and then in the generation phase. But in C++, this felt quite verbose, just not as good. This might be due to the verbosity of C++ lambdas, the tuples, right? It's not just 2 extra characters. It's a whole .get with angle brackets and stuff like that. Not very nice. And so while this technically worked, it didn't feel right. I wouldn't want to use that. And to get rid of this feeling of unease, I did something I would never expect myself to do. I gave in to the dark side. I gave in to the imperative and impure and mutable nature of C++. And instead of explicitly mapping and chaining generators in the generator phase, I started experimenting with what would happen if I made the generators depend on a global state, right? And suddenly I found myself migrating away from the purely functional way of doing things and I think I started doing what you are probably supposed to do in imperative language like C++. Hearing myself say this, it sounds horrifying, like I'm selling my soul, but it's actually, the end result is pretty nice. It might be worth it. It's not as bad. There are still, ways to encapsulate this cleanly under the hood. It's not like total anarchy. And it results in a much nicer code on the user level, I think. You just run your generators interleaved with the expectations, and things get automatically recorded behind the scenes, not on the generated value level, but on the test level. So a tiny takeaway, listen to the language. Yeah, you can have monads in JavaScript, Python, C++. Is it a good idea? I don't know, maybe yes, maybe not. For me, probably not. But yeah, in any case, experimenting with the approaches and being willing to compromise on some of the ideals from another language that don't really translate to another language helped me find, I think, a nicer developer experience. And I want to sell property testing to the C++ guys writing SerenityOS. I do not want to sell them pure functional programming. So, okay, with my goals aligned, I had the testing library written. There were still some ugly parts, like the one-off generator doesn't really work very nicely with functions. The type inference in C++ kind of sucks for lambdas. So it seems it will be possible with some black magic. Somebody tried to help me. The code they sent me didn't work, but I didn't want to just bother them any further. I think at this point it was like diminishing returns. Like, it's good enough. So the library is written, maybe not perfect, but usable. I put it up for a code review, and let me screenshot the pull request. Yeah, so we've had a few iterations. We've had some chat about it. Some, change requests. There was a lot. The SerenityOS project has high standards, so I think that's great. And after 100 plus comments and many rebases, force pushes to clean everything up and polish it to the codebase standards, Andrew Caster, who is the maintainer of the repository and another possible meaning of the AK acronym, said enough is enough and just merge the damn thing. And apparently I have hit his personal threshold. So yeah, it's good enough. So this meant the library was ready for use. Technically, it was in the master. Anybody could start using it for their test. So after losing my hair over stupid C++ errors, I can now cash it in. I can finally do something that I did this whole thing for. I can write some tests for the operating system. But where do I start? The code base is huge. Well, I actually knew already where to start because I had enough time to think about that during the whole review thing that took 2 or 3 weeks. And remember, I was introducing a whole new technique to the team or to the community. They don't know probably much about property-based testing. So I wanted some proof that this 2,000 line PR is useful, but also some guide on this is how you can do it. This is how you can use PBT. So I had some stuff ready. I gave a teaser in the PR with a round-trip test. This is probably about the most common property you will ever test. This one didn't find anything, and honestly, the AFL fuzzer is probably a better use case for that, for testing gzip compression and decompression, but yeah, seems like their gzip is fine. I found a different piece of code. This one had to deal with the IMAP, mails, with quoted printable encoding. That's the stuff in the URL that the percent signs and percent 3D is equal or whatever, equal sign. So the quoted printable encoding has a spec. it has an RFC spec. And those things are full of properties. And I was lucky enough to lay my eyes on the section 6.7 rule 3. And you all know it by heart, so I will need some audience participation. Let's recite it with me. No? Okay, no. So it talks about tabs and spaces at the end of the string and how they need to be handled, removed or preserved, stuff like that. And so, yeah, let's just generate those situations and see how it works, what it does. I generated a string made of literals, meaning the characters that will get preserved verbatim by the encoder, and appended a tab or a space, run the decode function, and it doesn't do what it's supposed to do. Turns out the code base is full of to-dos. They just do the minimal thing that works for the application, and deal with the rest later. That's probably a smart idea. And so it doesn't do what it's supposed to do. It doesn't strip away the tabs and spaces. And so I put this into a regression unit test, and I had my first success. Prove that this can relatively easily find bugs. But, you are waiting for the approval on your 2,000-line PR, so you keep busy. And I kept busy. My first instinct was to go find all the existing tests and see if there's any low-hanging fruit, anything where the authors, tested the happy path, but didn't test anything else. And there's a lot. There's a lot of stuff. This isn't even the entire file. I would need to make another screenshot. There are so many classes, so many existing tests. I started looking at some of those at random. In particular, the AK library has a bunch of data structures in it. And data structures are very nice for property testing. Very nice target. So my first target was the bitmap. Bitmap is basically an optimized version of a vector of bits or booleans. And the original tests were all creating bitmaps with sizes, the multiples of 8. And that's awfully convenient. That's kind of suspicious, if you ask me. I mean, that probably makes sense because with malloc and stuff like that, you are talking in bytes, right? So that might be making sense. But still, the bitmap API allows you to put any number in there, right? It doesn't have to be multiple of 8. And okay, I just put it in a property-based test. I didn't give any biases to my integer generator. And you say, give me number from 1 to whatever, and they will pick anything in between. And as I wrote the general property-based test, and it exercised all the arguments of those functions, it basically instantly found a bug. It didn't work if the bitmap size wasn't a multiple of 8, like I thought. In particular, it failed to find bits in the last partial byte. And so again, this felt like cheating. Like I wrote a test, it found a bug. So early? Like, shouldn't I have to work more to find bugs? And so I started investigating in the source code, like why does that happen? Turns out they have a helper function called size in bytes for a size of the bitmap in bytes, and it uses the ceiling division, right? So if you have 10 bits, it's 2 bytes, not 1. But some other code, when it tried to find something in the bitmap, it used flooring division. So that was interesting. I tried to, use the right thing. It also made the code look more high level, right? So sounds like a good thing to do, and that made it pass. And I had my first PR for just a bug found by the property-based testing. Then I did some more tests for the other functions. They just exercised all those functions, tested that everything works properly. Didn't find any bugs in the data structure, but tests are variable even when they're green. sometimes I have to remind myself of doing that, So then I stumbled upon the complex number class, and it had only one single unit test that I lovingly called the kitchen sink, because it tried to do everything in a single unit test. And so I started making things more organized, writing property-based tests for like specific functions, like the magnitude, phase, whatever, like conversions, trying to find as many properties as I could. And while most of them just confirmed that stuff worked, there were a few operators that actually did the wrong thing. And yeah, guess which operators weren't used in the kitchen sink test? So it was actually quite funny. Some of the operators didn't even compile once you started using them. I probably need some C++ expert to explain to me how that's possible. I thought it's gonna, type check stuff even if it's not used, but maybe some template magic is happening there. I don't know. But I started using them and it just didn't compile. So I had to, actually say, okay, this is scalar, not a complex number, so get rid of the real in there. And so, yeah, a few bug fixes were just like that. Then there were some copy-paste errors where, in C++ you have to overload operators for various like type pairs. So the code for like adding complex number to a scalar was fine, but there was also an operator for adding scalar to a complex number. And it used the same code, and it basically did, instead of like C minus 1, it did 1 minus C, which like that's fine for plus and multiplication, because those are commutative, but it's not fine for subtraction and division, right? And so, yeah, seeing that, I was kind of really glad I found this bug, because imagine you trying to write some application in there, some, I don't know, audio processing, some synthesizer, and suddenly some numbers just like start coming out wrong. And you don't know, like, how many layers deep could it be, right? So you have like fast Fourier transforms and like audio buffers, like all that stuff in between. Would you really think that complex numbers are buggy? For me, that's on the level of like the compiler is never wrong, the error is somewhere in your code. But here, the error was in the standard library. So yeah, I think that was quite sneaky one, and I'm glad we found it. And so that's where I will stop with the examples, but it's only scratching the surface. There's enough for everybody if you're interested. There's so many classes to pick from, so many applications, the system itself, the standard library, so many interesting things they are doing, and it's not being tested very well at all. Like, it's best effort, but that's probably not enough. And they have so many protocols they are implementing, like in the browser, HTML spec, CSS spec, JavaScript spec, all that stuff. People on their Discord sometimes are saying like, this piece of code that we are talking about in some other context, this could probably use property-based tests. And yeah. So I want to end with a summary and maybe a call to action. First of all, property testing is huge fun and finds tricky edge cases that you are too lazy to think of or can't even think of. I recommend trying it out if you haven't, making it part of your toolkit, part of your skill set. Secondly, if you are ever implementing property testing library, maybe go take a look at what Hypothesis does, like example database, this like internal shrinking. They are doing a lot of cool stuff that makes it feel very polished, and I think makes people want to stay and test more. And next up, if you are coming to an OO language from an FP world, know that the app solutionist approach is not helpful. Like, you cannot be, too fundamentalist about like, this is the best way to do things, right? It will only take you so far. There are diminishing returns. Sometimes it's best to act, like to behave according to the customs of the people you are living with, right? So, yeah, immutability, sure, purity, sure, they do make sense, but there's diminishing returns, and sometimes if you are writing C++, maybe look at how people write C++ instead of trying to write Elm in C++. And finally, if you want to get some experience writing property-based tests, if you want to practice finding properties, if you would like to contribute to some open source project, take a look at SerenityOS. Like, I mean it. If you want to get some experience writing property-based tests, this is a great opportunity. I think you will not have much work trying to find some bug. There's going to be a lot. And I think they are going to be very happy when you go find those. So the foundations have been built, the PR is merged, the property test runner is there. There are some example property tests. And if you want, I can help you like get up to speed. Just come join the SerenityOS Discord, ping me, and I'll be happy to like mentor you if you want. And yeah, you'll make that project better in the process. So come learn property testing by contributing to SerenityOS. Thank you.
Thank you, Martin, for a fascinating talk. So we do have time for questions, but Maya, if you could be setting up at the same time, please, so that we can continue.
Hi, thank you very much for the talk. These test cases that you mentioned, were they run on SerenityOS or were they running them on a different host system?
That's run outside of SerenityOS. You can run the test inside, but people are usually developing the system outside of it. Yeah.
Yeah, the C++ projects, when someone decides to rewrite the STL, is an amazing treasure. There's always like 20 bugs in that new STL. But the thing is, so in the C++ world, what's the difference between the hypothesis library and rapid check, if you are familiar with that one?
I'm not familiar with it.
Okay.
Sorry.
And the second question, like a follow-up different thing is, I found property-based tests extremely useful as stand-in for unit tests, right? You have your data structure, you define some properties, and life is good. But then you move on to that higher level of complex parts of the system, and I found it very hard to find those properties. Like you end up having to write unit-like tests anyways, because those are the only things you can reason about. Unless you don't, like, do you have any advice for, like, for instance, if you're writing an API, right, where users sign in, is there a way to define properties at such a high level?
Yeah, I think it probably all depends on the API of the thing that you want to test, and like, I probably don't have any like quick, easy advice. But it's just like, for me, like a lot of the stuff they are doing in SerenityOS is based on a spec. So when I was doing PBT in Elm, there wasn't that. So I just had to like find my own like laws and stuff. But there, like for me, that was a new thing where the spec actually says, when you run this protocol, like this message, he sends that, you send that, something should happen. Like, they spell it out. So that might be, in the context of this specific project, that might be a good way to like try and find these properties for these like high-level things.